In this lecture, we're going to talk about access control systems. They can either be centralized or decentralized, and that can also be referred to as distributed. In most cases, though, we're probably going to use some sort of hybrid because both of them have unique advantages and disadvantages. The access control systems compare my credentials to an access control list. I swipe my card, I type in the access code that I have on the keypad or use my fingerprint as the authenticator, then the system checks against the access control list. Is Thor allowed in this room? If I am, it grants me access, the door opens. If I'm not, it doesn't. The most common types would be like the one you see over here on the right. It is a star topology that can also sometimes be referred to as a hub and spoke. Like if you think of the wheel on an old wagon like a wooden wheel, or on a bicycle. The center is the hub. Everything out from that goes to the actual tire, those are spokes. So the black thing you can see here in the middle, that's the one I swipe my key card to, or I punch in my PIN or my fingerprint or whatever. That is the interface I interact with. That is then connected to the actual lock. It is connected to a door contact. An emergency exit button that would normally be on the other side of the wall. In most places, we would have the access control going into the room, not leaving the room. We want a secure exit. And then the actual arrow up that goes to the main panel, the actual access control system. Most of the ones we use today uses role-based access control. Let's say this door is to the data center. If Thor is on the data center team, well then Thor gets access. We are also seeing more and more of a move towards attribute-based access control. Here, users have signed attributes. Let's say I'm not on the server team, I am a project manager. Well then, I wouldn't have access. But if one of my projects involves the server team or I'm doing a project for them, well then, I might have access. But the rest of the project managers would still not. If you look at the image here on this slide, this is a more accurate version of how an actual control system might look, but a tiny version of it. You have the 4 doors here, then you have a switch, and then you have the actual access control server. In many places, this can be 20, 50, 100, or 500 actual spokes on that hub. It really depends on how secure our facility is and how much we need to segment who can access what. Since it's normal for doors like this and entry points to be dispersed throughout the entire organization in all our buildings, it is pretty common just to tack them on, use the existing infrastructure. We just segment access control off to its own VLAN, but in the perfect world, rainbows and unicorns, we would have an entire network just for access control. And the reason for this is we are not super good about securing our network in the wiring closets or wherever we have network equipment. I have worked in places where in the bathroom, yes, the bathroom that everybody can access, there's a switch just hanging somewhere in the ceiling with no security at all. Anyone can plug something into that switch. So if at all possible, run this outside the normal network, but I don't think I've worked anywhere where we actually did that. Now, let's look at some of the cons and the pros of centralized versus decentralized access control systems. And it's pretty easy to keep track of. All the stuff that is good about centralized are the things that are bad about decentralized. The other way around, the things that are bad about centralized are the things that are good about decentralized. And centralized really just means that all the decisions are made at a centralized point. Let's say we have 10 facilities and we have the access control server at our main facility. Then all the other 9 facilities, every time they need to make a decision, should I open this door for Thor or not, they have to contact the centralized server. Since everything is on one server, it's obviously much easier to manage. We have all the records in one place. We can do one configuration, and we can ensure that all the policies and procedures are followed because we only have that one system we need to look at. We all know that the attacker is going to look for the weakest link. If we had a bunch of places where we had access control servers, well then maybe some tiny satellite office somewhere would not completely adhere to our security policies and procedures. They would be an easy entry point for an attack. If we have a centralized system, well then only very few people would have access to the system, This can give us some separation of duties, meaning the admins at the satellite location can't log in and change the access rights for their system. And then as the final pro for centralized, we can use SSO, single sign-on, that gives a user access to multiple systems with a single logon. And now for the not so good things about centralized. How long does it take from the access control system on the door to send a request to the access control server at the main location, and how long does it take for that reply to get back to the door? What if the satellite location has a really bad internet connection, or it's down, or it has really high latency? So to get the best of both worlds, we most often use hybrid systems. We still have the centralized main access control server, but we also have smaller access control servers at each location. The local admins have no access to the local servers, and every so often we push out any changes to the access control list. That can be every hour or every day or whenever there is a change to the list. At some point in my career, I was the IT manager for a credit union in California, and we had a branch that was about an hour away from our main data centers, and they had this exact problem. On a pretty regular schedule, the internet would go down. So one of our large projects was to ensure they had stable, redundant internet. But on top of that, we also moved a decentralized version of the access control server into each branch. So even if the internet was down or just the connection to the main data center, they could still get into the rooms they needed to do their work. And the same little warning you get every so often from me, we need to make sure that the implementation is equally secure in all locations, or at least secure enough. What if the security at that satellite location is really bad? The physical security, the logical security. Can someone just walk in and grab the server? It's the same concept we talked about with physical security. The walls, the windows, the doors have to be equally secure, and since they're not that inherently, well then we need to reinforce them. This is the same concept. Every single office should be equally secure, because if they're not, the attacker will find the weakest link and exploit that. And I understand, most satellite offices won't be as secure as our data center. They don't have to. They have to be secure enough. Next up, we have JIT access control, or just in time. And JIT allows us to use third-party websites without confirming that all of our employees have accounts on those sites. Let's say our organization wants to thank our employees, and for each year they have been employed with us, we give them 100 points to spend on whatever they want on a random website. Now, instead of exporting a giant Excel spreadsheet with all our employees the day they joined, sending that to the company, having them create accounts for everybody, and then having to send them 10 or hundreds of new accounts and removing accounts every day when people join and leave the organization, instead, we can use JIT. The employee logs in to their normal work account. Then on their first visit to the third-party website, that website confirms they're an employee of ours. It confirms how long they have been employed, so it knows how many points to give them, and it creates the account. And this is something that normally is done using SAML. Much easier, less administrative overhead, and much cheaper. Next up, we have OpenID Connect, OIDC, or Open Authorization. And all that really does is it adds another layer, an identity layer, to OAuth 2.0, and that allows third-party applications or sites to verify the identity of a user. I'm sure you've seen them in a ton of places. Use your Google or Facebook account to log in here. You don't have to create an account. It piggybacks on your existing account. And then finally, let's talk about risk-based access control. So every time access is granted to certain systems or everything or certain areas, it is based on a risk assessment. And this is done through machine learning. It will look at your behavior, the concept of data analysis, and calculate how risky is this access to allow. Are there any indicators here that granting risk could pose a risk? Let's say you log in from an IP you've never logged in from before. That could be a red flag. Or have you never logged in past 5 o'clock in the afternoon, and then all of a sudden you log in at 2 in the morning? Or are you using a user agent HTTP header that you haven't before? And if you don't know what that is, well, it's really any software that acts on your behalf and I'm going to just read the actual definition, retrieve, render, and facilitate end-user interaction with web content. So in less fancy words, that can just be a web browser. But again, if you have for 5 years logged in using Google Chrome, and then all of a sudden your account logs in using Firefox, again, it could be a red flag. And with that, we are done with this lecture. I will see you in the next one.